If you're an IT worker and you're scared your job is being taken away, don't be. I'm going to give you a clear vision of how IT work is actually evolving. To see where it's going, we have to go back. We have to understand where IT work came from. Every server, every laptop, every firewall, every line of code you've ever written, it all started with one genius idea. That idea came from John von Neumann in the 1940s. He laid down an architecture so simple it still runs every computer on Earth. A CPU, memory, and instructions stored in that memory. The CPU reads one instruction, executes it, moves to the next, that's it. Deterministic, same input, same output, every time. This is the first pillar. Then came the second revolution, object-oriented programming. Instead of writing instructions one by one, engineers started thinking in objects. The powerful part, inheritance. Take a single firewall vendor. They ship dozens of models, entry level, mid range, enterprise, data center, different hardware, different price tags, but every one of them inherits from the same base firewall class. They all block, they all log, they all enforce policy. The vendor writes the base once, and every model picks it up. That's the second pillar, abstraction. And there's a third pillar, logic. Every if statement, every loop, every troubleshooting session. Be honest, if you're in IT, you've been doing three things: writing logic, configuring systems, and debugging. That's been the job for decades. Now here's where it changes. We are entering a new era, the era of machine learning. But here's how I want you to think about it. For machines, we call it machine learning. For humans, it's easier to understand if we call it what it really is, learning systems. And a learning system is fundamentally different from everything that came before. One Neumann is deterministic, OOP is deterministic. Same input, same output. A learning system is probabilistic. You give it an input and it gives you back a probability, not a guaranteed answer. A best guess with a confidence score. And here's the important part. The learning system sits on top of the von Neumann architecture. It doesn't replace it, it runs on it. Underneath, it's still push, pop, registers, instructions, but on top, a new architecture has emerged. One that produces probability scores instead of deterministic answers. So let's bring it all together. For 80 years, IT ran on three pillars: determinism, abstraction, and logic. You decided what should happen. You wrote the if statement, you wrote the loop, you configured the system. The machine just executed your instructions. Now flip it. In a probabilistic system, you don't tell the machine what to do step by step. You give it a goal, the model looks at the situation, weighs the possibilities, and produces a probability for each possible action. Block this packet, 87% confidence. Escalate this ticket, 63%. Roll back this deployment, 91%. Then an agent picks the highest confidence action and executes it, using the old von Neumann world underneath. The model decides, the deterministic system carries it out. That's the loop. Logic still exists, but it's wrapped around the model now. Determinism still exists, but it's the execution layer, not the decision layer. Three pillars didn't go away. A fourth pillar got added on top, probability. And that fourth pillar is where every new IT job lives. So where do you fit in? It splits into 5 evolution tracks. Track 1, machine learning engineers. These are the engineers who build and perfect the probabilistic models themselves. Linear algebra, calculus, training pipelines, model architectures, they make the engine. Track 2, deployment engineers. They take these probabilistic models and integrate them into the enterprise. APIs, CLIs, MCP servers, production infrastructure. They bridge the new AI world with the existing von Neumann world that runs every company on Earth. Track 3, custom model and RAG engineers. They build custom models on company-specific data. They design retrieval pipelines, fine-tuning workflows, and orchestration loops that make a generic LLM behave like a domain expert. Track 4, AI application engineers. They build the products on top, apps that generate video, write code, analyze documents, design interfaces. They turn the model into an experience. Track 5, AI-powered cybersecurity engineers. They sit at the terminal, wire up CLC probabilistic models, and use them to analyze threats, hunt anomalies, and respond at machine speed. This is where defenders catch up with attackers. So if you've been worried that IT work is going away, flip it. IT work just became more powerful than it has ever been. If this gave you clarity, follow me on LinkedIn and YouTube. That's where I break down how IT, AI, and cybersecurity are evolving, one idea at a time. See you in the next one.